The cost of modern battlefield survival has officially shattered the traditional air defense equation. Right now, on simulated battlefields across the Western and Southern Theater Commands, multi-million-dollar tactical networks are being left completely exposed and defenseless against the relentless saturation of $2,000 suicide drones. To address this exact vulnerability, the PLA has rapidly expanded the mass deployment of China PLB-625, an integrated mobile air defense system designed specifically to render the swarm tactics of modern drones entirely useless. For years, military planners in foreign nations relied on advanced missile networks, but the harsh reality of global attrition warfare shows that discharging a $300,000 surface-to-air missile to intercept a cheap loitering munition leads straight to economic bankruptcy. Leading global defense analysts argue that, on paper, their only tactical salvation would be an ultra-high rate of fire system capable of sustaining a localized Iron Dome for forward-deployed mechanized units. This has propelled China PLB-625 into the spotlight as the ultimate anti-drone shield. Merging a 6-barrel 25mm Gatling gun with advanced radar guidance, this 8x8 armored platform creates a literal wall of flying fragments. This specific configuration allows it to counter waves of low-altitude threats before they can spot vulnerable troop columns. With the Pentagon accelerating its replicator initiative to deploy thousands of autonomous aerial systems in the Indo-Pacific by late 2026, China PLB-625 has transitioned from a mere prototype at the Zhuhai Air Show into a critical strategic asset. Before we go on, do you think automated rapid-fire guns are truly the future of battlefield survival? Or will autonomous drones eventually bypass these defenses? Hit subscribe to join our community and tell me where you are watching from. To understand why this 8x8 armored platform creates such deep tactical apprehension among foreign military strategists, one must examine the precise electronic and ballistic architecture under the hood. At the core of China PLB-625 is an active electronically scanned array radar, commonly known as an ESA radar, mounted directly on top of the turret. This digital tracking system operates on high-frequency bands designed to identify micro-aerial vehicles with a radar cross-section of less than 0.01 square meters at a range of 10 kilometers. Conventional short-range air defense platforms often suffer from target saturation, leaving armored columns exposed when facing more than a dozen threats simultaneously. However, China PLB-625 bypasses this physical limitation by combining its primary sensor with an advanced electro-optical and infrared tracking system, allowing for passive target acquisition without emitting thermal or radio signals. Once the digital threat profile is locked, the platform engages its primary weapon, a 6-barrel 25mm Gatling gun with a maximum rate of fire reaching 5,000 rounds per minute. While a high volume of fire is standard for mechanized defense, the integration of advanced ammunition, known as a head technology, shifts the tactical balance. As each 25mm round passes through the muzzle sensor, the onboard ballistic computer programs a microchip inside the fuse within microseconds. Instead of relying on a direct impact, the projectile detonates at a calculated distance directly in front of the incoming aerial vehicle, releasing a conical cloud of hundreds of heavy tungsten pellets. This creates an impenetrable localized barrier that completely shreds the propulsion systems and delicate optical arrays of autonomous weapons. By replacing $300,000 missiles with bursts of specialized 25mm ammunition, costing less than $1,000 per engagement, this platform successfully addresses the critical economic imbalance of attrition warfare. This technological integration has fundamentally reshaped the strategic landscape across the Indo-Pacific region through the mid-portion of 2026. The deployment of China PLB-625 is no longer confined to isolated research facilities, as intelligence reports confirm mass production variants are actively embedded within medium combined arms brigades. Operating on the versatile 8x8 wheeled chassis derived from the ZBL-08 armored vehicle, this tactical shield achieves a maximum road speed of 95 km per hour, allowing it to maintain pace with rapid offensive maneuvers. On the modern battlefield, China PLB-625 is designed to operate as the crucial inner layer of a comprehensive network defense matrix. It directly complements the medium-range track-based HQ-17, a missile system, filling the dangerous short-range gap where high-altitude radar networks lose tracking fidelity against low-altitude terrain-hugging threats. To extend its defensive perimeter before engaging its Gatling gun, the turret is equipped with up to 8 FN-16 or HN-6B short-range surface-to-air missiles, providing a secondary layer of interception out to 6 kilometers. Tunnels and coastal deployment zones within the Eastern and Southern Theater Commands have seen a significant influx of these systems, signaling a direct response to foreign distributed lethality concepts. Independent defense research institutes suggest that this rapid integration directly complicates the deployment of large-scale autonomous aerial swarms in restricted littoral corridors. By establishing a continuous 60,000 square meter bubble of low-altitude denial around moving columns, this integrated system challenges the basic assumptions of modern air superiority, forcing regional military planners to reevaluate the survival rate of tactical electronic assets in contested airspace over the next 12 months. Despite its formidable presence, the rapid expansion of China PLB-625 introduces a profound logistical paradox that intensifies the debate between conflicting military doctrines. While the platform utilizes a 25mm configuration to maximize its internal magazine capacity and prolong tactical endurance against mass swarms, it must accept physical trade-offs in kinetic energy and effective range when compared to heavier 35mm systems. Furthermore, global supply chain analysts point out that sustaining a high rate of fire with advanced programmable ammunition requires a continuous flow of specialized microchips to manufacture millions of intelligent fuses. In a prolonged near-peer confrontation, any disruption to semiconductor production could reduce China PLB-625 from a digital shield to a conventional anti-aircraft gun, decreasing its low-altitude intercept efficiency by more than 50%. This critical dependency highlights a strategic lesson for 2026, which is that tactical dominance is no longer determined solely by the sophistication of a weapon system, but by the industrial capacity to mass-produce its components under extreme duress. As global defense architectures diverge, military planners face a definitive choice between investing in expensive precision-guided missiles or deploying high-volume combat platforms designed for economic sustainability. China PLB-625 represents an industrial bet on volume and cost efficiency, attempting to turn the economic logic of drone warfare completely against its creators. If this doctrine succeeds, the traditional concepts of air superiority will require a fundamental rewrite. Do you believe that high-speed kinetic guns using intelligent ammunition will permanently marginalize the role of missiles in short-range air defense? Or will the vulnerabilities in semiconductor supply chains eventually undermine this entire strategy? Share your technical analysis in the comments below, and if you found this deep dive valuable, hit the like button and subscribe for more in-depth defense analysis.